All right, top of page 571. And today we're working with and talking about inverse trig ratios. Yes, you have to watch yesterday's notes for today's notes to make sense. It's up to you. I don't know. I'm talking right now. All right. So yesterday you found the sine, cosine, and tangent of angles. All right. So in words, what you need to understand about today is this: if angle A is an acute angle, and the sine of A is x, a fraction or a decimal, then the inverse sine of A the inverse sine of x is the measure of angle A. If angle A is an acute angle and the sine of angle A is x, then the inverse sine of x is the measure of angle A. So here's the symbol. If sine of A equals x, then when you see this sine -1, you read it as inverse sine. So what this says so far is that if the sine of A equals x, then the inverse sine of x equals the measure of angle A. This is all actually very simple. It doesn't sound like it yet, but trust me. So let's get two other symbols down now that you know what the symbol or how the symbol and the words relate. We can also say that if cosine of angle B is equal to x, then inverse cosine of x is equal to the measure of angle B. What they're saying is if you know the sine or cosine of an angle and you push some calculator buttons, you can find the measure of the angle. If tangent of angle C equals x, then inverse tangent of x is equal to the measure of angle C. Here's how this works. Look at example 4 on page 571. And we've got a triangle there. a right triangle ABC. The hypotenuse is 27 and BC is 18. And you need to find the measure of angle A. Now, it is extremely helpful to always have the acronym SOHCAHTOA on your paper so that you can reference it quickly when you're using trig and inverse trig ratios. Okay? We're going to find the measure of angle A here. We're going to use SOHCAHTOA and we're going to use inverse of SOHCAHTOA. So here's the measure of angle A, or here's angle A. In relation to angle A, we are given the opposite and the hypotenuse. And the ratio that deals with opposite and hypotenuse is sine. So watch. If we know the sine of angle A, if you go back to your symbol, if you know the sine of angle A equals x, then the inverse of x equals the measure of angle A. Okay? So watch. The measure of angle A is equal to, since we're dealing with opposite and hypotenuse, we're going to use the inverse of sine. So we say inverse sine of opposite over hypotenuse. So here's your sequence in the calculator. You type 18 over 27. You push the second button and then you push sine and equals. And your calculator should say 41.8. No, you push 18, fraction button 27, second button sine. Does everybody get 41.8? Very good. Now, if we needed the measure of angle B, wouldn't that be equal to 90 minus 41.8? Because the two acute angles in a right triangle are complementary. So let's find angle B over here. And I get 48.2. Let's try it again. Here's our triangle. I'm on the bottom of page 571 doing 4A. Triangle ABC again. B to C is 6. C to A is 20. We're finding the measure of angle A. Where's my acronym? All right. In relation to angle A, which sides are we working with? Good, that's opposite and adjacent. There's opposite and adjacent. Tangent. So we're going to say the measure of angle A is equal to the inverse tangent of our opposite side over our adjacent side. So we type 6 fraction button 20 in the calculator, second tan, and your calculator should say 16.7 degrees. So then to find the measure of angle B, we do 90 minus 16.7. $73.3. Are you getting the same numbers?
Wait, so what makes you tan instead of...
We're using tan instead of sine because based on the given information, we needed angle A, but we were given its opposite side and its adjacent side. Opposite and adjacent is tangent. In order to use sine, we need the opposite side and the hypotenuse. And in order to use cosine, we need the adjacent side and the hypotenuse. So the given information is what tells you which of the ratios to use. So let's look at 4B there. Another triangle ABC. We got a side that's 15 and a side that's 3. We're still finding the measure of angle A first. So the measure of angle A is equal to, what sides are we dealing with in relation to A? Adjacent and hypotenuse. So inverse cosine of the adjacent side over the hypotenuse gives us the angle measure. $78.5. Now let's do the measure of angle B instead of subtracting from 90. Let's use inverse trig ratios. If we say the measure of angle B is equal to, in relation to angle B, which sides do we have? Opposite and hypotenuse. So which ratio is that? Very good. So again, 3/15. Second sine, 11.5.
Also subtract 78.5.
He just said that it's just because he just wanted to show that it didn't work.
Thank you. Thank you. It's going to depend on, see, the directions today say use the calculator to find the measure of angle A to the nearest tenth. All right, so just depends on what it says.
All right.
Now, where you will most definitely get into a problem is if you don't type this fraction straight into the calculator. If you take 3 and divide it by 15, you get like 0.2. And then if I go like second fix 4 and I do 3 divided by 15, it's still 0.2. There's some decimals that the calculator will knock digits off the end because of where you're rounding it. And if you use that decimal for the inverse sine, cosine, or tangent, you'll get a different angle measure. Well, what'll happen is sometimes if you drop off too many digits, in what the fraction equals, and you use second cos or second sine or second tan, your angle measure will be off by 2 or 3 sometimes. So way back when kids weren't allowed to use these calculators even for this class, they had to round their sine, cosine, and tangent 4 decimal places. Because the difference between like second cos of 0.42 and second cos of 0.455 was the difference of an angle measure of sometimes 2 degrees, which is a big difference.
So use fraction.
You just use the fraction. Use the fraction because the calculator is then using all of the digits of the fraction. Make sense? All right, y'all think you got it on finding angle measures? Let's see one more. Let's do this. Let's do this triangle XYZ. We got a 5 and a 9. Here's X and Y. And let's say you got to solve for X and Y. So if you have to solve for X and Y, which one are you going to solve for first? It doesn't matter. You're exactly right. Because once you find one, you can find the other one, right? So let's do the Y. The measure of angle Y is equal to, we've got opposite and adjacent. So we're using tan. Opposite side over adjacent side. All right, so 5/9 second tan. 29.05, we're going to call that 29.1. So now I'm not going to subtract that from 90. I'm just going to use inverse again. So the measure of angle X is equal to, for X, which ratio are we using? We've got opposite and adjacent, so we're using tan again. And now it's 9/5. $60.9. All right then, so your practice for today. It's going to start on page 573. Twelve through 14. And then 36 through 41. And I need you to find both angles. Find both angle measures in each problem. For your own benefit, I would find both of the angle measures using your ratios and not finding one and then subtracting from 90. You'll benefit come quiz day. Any questions?